Excellent. So I'm going to talk about threats and opportunities in construction supply chains. So this is a very wide topic. I always prepare too many slides to be able to fit into an hour presentation. So please forgive me in advance if I have to fly through some of that material. But of course, during the Q&A, you can stop me and ask any question that you want. And in fact, for practical reasons, if you want to raise your hand and stop me and ask for additional explanation in the middle of the presentation, that's okay too. I welcome that. I'm used to that because in the US, my students do it all the time. And that seems to be sometimes more practical. Sometimes you forget what question you wanted to ask in the that you wanted to ask in the middle of the presentation. By the time we get to Q&A, unless you jot it down for yourself, you may forget. So feel free to interrupt at any time. So this is the outline of the presentation. Can everybody see that okay? I want to talk about first traditional supply chain and what are the issues that we're facing, but in particular, because we're still in the midst of the pandemic, COVID-19, I want to say a few words about what impact COVID-19 has on construction supply chains. I've just had a few students in my e-construction group who completed their thesis work on that subject, so I want to share a little bit of those details as well. But most of the time, I wanted to focus on disruptions to supply chains due to technology and how disruptive some of the ideas and some of the new approaches will be to the supply chains that we're already familiar with. One example of technology that I want to focus a little bit on is 3D printing. Here I must say that I owe a great depth of gratitude to Dr. Svetlana Besklubova, who fairly recently completed her doctoral work at Hong Kong UST and in the area of construction productivity under Professor Eric Zhang. And she served as my research assistant or teaching assistant rather when I was a visiting professor and visiting fellow at the Jockey Club Institute for Advanced Study and taught automation and robotics there. And then she also was a visiting doctoral scholar at the University of Maryland, working in my research group. And we've done quite a bit of work in the logistics related to 3D printing in construction. So Svetlana was really instrumental in putting this material together. And so one aspect of that work that I want to focus on at the end of the presentation is the 3D printing technology capability map, specifically for the Hong Kong region. That's the outline of what I want to talk about today. So this is a traditional supply chain. All of you who are researching construction know that modern supply chains are inherently complex and they comprise geographically disjointed entities competing to serve consumers. So that's a complex, dynamic, and changing size, shape, and configurations over time. Simply because we have to deliver material, we have to deliver equipment, we have to deal with expertise of multiple professionals to make a construction project happen. Nowhere is it more apparent than in Hong Kong, because Hong Kong is a very international city and of course very closely tied to mainland China industries, but has a distinct characteristics of being a former British colony. So also a lot of British and continental European and in fact US work practices as well. And that makes it a living laboratory for what construction supply chains would actually look like. in the most complex environments in the world. Supply chain management, of course, is a very, very important issue. And it's defined as a system where suppliers, contractors, clients, and their agents work together in coordination to install and utilize information in order to produce, deliver materials, plant, temporary works, equipment, labor, and any other resources for construction projects. So as complex as these projects are, they require a variety of expertise, a variety of services and materials and equipment. And the more complex the project, the more complex the supply chain management issue becomes. All right, so this is a traditional supply chain. Everybody can see this drawing. Now we have raw materials that get processed in materials factories. This could be actually a quarry, a stone quarry delivering its material to crushing plants, and then that material being used for batch concrete production. So that's just one example of that, but not exclusive, of course. This could be iron ore that is being processed to produce steel reinforcement bars. Then out of those factories come construction materials, but also tools and equipment. Remember that most of the construction equipment requires steel. So of course, the raw material for steel is iron ore. So all of that has to happen before the materials and tools and equipment are delivered to project sites. And of course, we have construction trades, workers of different construction specialties. We have construction design professionals that design not only the structures themselves, but also the construction processes that need to be meticulously designed. And all of that actually combines into the construction product assembly. And the assembly may be as complex or as simple as it gets, depending on what kinds of technology is being used. So we have a variety of issues that we're dealing with in a traditional supply chain. What are the management issues in the construction supply chain? First of all, this is one of the most waste-producing industries of any. We have high inventories of materials and equipment. The activity cycle times may be very long. That results in the production of waste. In the United States, for example, about 60% of the total volume of solid waste in municipal waste sites come from either new construction or from demolition. So that's a big challenge for us, because most of the municipal areas in the US and in fact elsewhere in the world are quickly running out of space. Because it's such a convoluted process and so many disjointed activities by so many multiple parties, we have a number of miscommunications resulting in errors in planning, design, and then the execution of construction stage of the process. So we have, unfortunately, the transfer of these errors from the early stages of the supply chains to later stages. And we have to worry about how these errors propagate throughout the entire process. And we also have a problem with ensuring high quality standards, because multiple contractors and subcontractors work based on their own industry norms, and sometimes the coordination of these standards, what needs to be delivered, is not an easy task. Lack of effective coordination and collaboration systems has been a hallmark of supply chain issues in construction, because of the multitude of interests and multitude of professionals. Also, construction is viewed as one of the least innovative industries, one of the low-tech industries, as opposed to high-tech manufacturing. Of course, we're trying to change that with our research and development activities. So my distinguished colleagues like Professor Pan or Professor Lee are in the forefront of these activities, but yet the industry as a whole still suffers from a relative lack of innovation. And then we have this fragmentation issue that I keep alluding to because the nature of the industry and the size of the projects that sometimes require multiple parties to be involved in the project, not only at the same time, but throughout the entire life cycle of the project. All right, so what are the other characteristics? We have short-term relationships. It's a nature of a project that the relationship between the parties is temporary in nature, and it ceases to exist as soon as the project is over. The parties may reconnect on other projects in the future, but that, of course, is it's not guaranteed, and this is something that might or might not happen. So these short-term relationships, unfortunately, create a very litigious nature of this industry because big money is at stake and it's changing hands. And if the parties don't have the contract documentation put together in perfect clarity, then some misunderstandings may ensue. So in many projects, we have a situation in which there is a lack of mechanism for rapid resolution of problems. Especially misunderstandings and handling design errors. We're striving for that. We have mechanisms in the industry that make it happen, but unfortunately in industry practice, it's not always easy. And then we have a lack of evaluating the interface system between project lifecycle phases and that sometimes creates a situation in which errors committed on one project get repeated, unfortunately, on future projects as well. This is more or less a knowledge management issue, but it becomes quite acute when we have to repeat the same mistakes. Sometimes there is a lack of transparency because the contractors and subcontractors operate on a need-to-know basis, and some of the information related to their part of the project is considered highly confidential, and in fact competitive data such as productivity data of a particular contractor or subcontractor never get shared with other participants in the project. So we have these inefficient transactions where there is a lack of information transfer. We also have fraud because of course every industry where big money is changing hands is an invitation to fraud. So we have to make sure that that we eliminate that to the highest possible extent, but it's hard to eliminate it completely. And we have pilferage also, unfortunately. Bechtel Corporation, for example, tells me in the US that they lose approximately $1.5 million worth of hand-hand tools. Why? Well, these tools somehow they grow feet on project sites and walk away from the job together with the workers. And it's very hard to keep close tabs on where these tools are at any point in time. There are, of course, solutions to that, barcoding these tools and check-in, check-out systems. And so some unions actually require workers to purchase their own tools, and they get reimbursed on a gradual basis for these tools on an amortization basis. But it's never completely easy. So the supply chains have to really deal with it. So what are the influences of COVID-19 on supply chains? And this is something I want to spend a little bit of time on because the topic is so hot right now. One of the failure points is that the suppliers are unable to fulfill orders due to labor shortages. Workers get sick and they just don't deliver the products and services on time because some of the workers are very hard to replace on the short-term basis. So the impact is, of course, stalled production, unfulfilled orders, the so-called bullwhip effect. Actually, these problems propagate through the entire project as the work progresses. We have transportation restrictions and lower capacity for distributors to send goods. Why? Quarantine requirements in various countries, lack of air connections or train connections between various parts of the world or countries because of the coronavirus restrictions. So we have uneven arrival of needed raw materials, and that causes stalled production as well. We have understaffed companies due to quarantines and medical safety, and sometimes lower supplies of not just labor, but also products. So we have slow shipments and inconsistencies in deliveries. Items that are being awaited for just-in-time delivery just don't show up, and that causes the need to store materials in the future, to reshuffle schedules, and that becomes a problem as well. So we have, again, transportation restrictions, limited delivery possibilities, inflated delivery costs, sometimes because of the lack of deliveries using traditional modes of transportation, that can actually jack up the cost as well. Sometimes to the point that deliveries just fail to materialize. So we have understaffed contractors and suppliers, undersupplied vendors. There are some store closures due to the fact that some businesses don't manage to survive because of the problems in the supply chains. Sometimes that's because the insufficient number of consumers of the products that these companies produce. So less products actually on suppliers' shelves, diminished quality to serve customers, limited choices that these customers would serve. So, and then this is also a specific problem. Companies unable to find drivers to be able to deliver products across different jurisdictions, and lack of demand for certain goods. If there is lack of demand and the inventories are high, of course that causes part of the bullwhip effect. The companies upstream will not produce, and that would run into economic troubles as well. So inconsistent deliveries, model for timing is faulty, and increased costs. Why? Because some of the so-called force majeure clauses in contract documents don't cover situations such as pandemics, only cover natural disasters. And a lot of litigation in US courts right now between companies that are trying to include COVID-19 as a pandemic, as a force majeure, and yet the opposite parties are arguing that force majeure was only intended for natural disasters. So that's the issue that we're grappling with. Unable to reach end consumers due to lack of delivery options. So shipping is an issue. I already mentioned delayed deliveries. More volatile demand patterns that, for example, prefabrication factories are having a hard time coping with that simply because of these interruptions based on COVID-19. So what happens to sustainability in supply chains post-COVID-19? Once we already managed to survive this pandemic and the issues that we're facing today slowly disappear because of sufficient vaccination numbers, we have to look at what are the lessons learned from the current pandemic. So we look at the long-term strategic role of Industry 4.0 technologies as an enabler for crisis management. And in fact, if we look at what these technologies offer and what they are, Just quickly, I want to mention that last year I contributed a chapter on automation and robotics to a construction 4.0 monograph that was published by Taylor and Francis Rutledge, which is one of their subsidiaries. So those of you who haven't seen that book, I highly recommend it to you, because there are many relevant issues being discussed, from blockchain technologies through automation, construction, sensor-based systems, and the like. A lot of interesting information on what construction 4.0 technologies can actually do for the industry. So big data can be reinforced as a decision planning tool, and quickly respond, or allow us to respond to crisis. Big data management for the construction industry is just something that a lot of researchers are getting involved in, and a lot of consulting companies are very interested in that subject as well. So I already mentioned blockchain. Blockchains can actually support sustainability, not only from the environmental sense, but also from the economic sense. When you can have proper amounts of products and services delivered onto the project sites, and then the transactions between various stages of the project, transactions related to materials and services can be handled using blockchain technology. I mentioned sensor-based systems, so localization through various technologies can also benefit greatly the construction industry supply chains. Smart factories in crisis can support supply chain sustainability, and here comes the role of additive manufacturing and robotics for that purpose. Very important technologies. Then building agility through technological innovations may result in wasted resources, burdening supply chain sustainability. So we have to look at whether agility through technological innovation is really something that we want to focus on as far as supply chain sustainability. Sometimes the solutions that we're trying to implement in the industry may end up working cross purposes. So that's something that some of my students are looking at right now as well. So social distancing, remote work that we are experiencing today means sort of a crash course in greater acceptance of conferencing technology and less travel to supplier locations for monitoring, negotiations, and so forth. So the fact that we're having this lecture online through Zoom today is a testimony to the fact that the world, including ourselves, have already adjusted to the use of these technologies. So of course, it's not the best option, but it's the second best option that we can put up with at this point in time. So online sourcing and purchasing of retail and groceries, shift travel, and last mile delivery focus affecting sustainability. Of course, there are sustainability aspects of it as well, but in construction materials supply chains, using online sourcing and purchasing can not only result in greater sustainability, but it can also result in realizing the economies of scale that sometimes were not particularly paid attention to in the past. I don't want to run this video because of lack of time or limited time that we have, but I want to emphasize that disruptive technologies that are evident in our industry today are also capable of changing the basis of competition by changing the performance metrics along which firms compete. So some of the old metrics that were present for supply chain management may no longer be valid, given the fact that we are living in the pandemic world, that we have our construction 4.0 technologies at our disposal, and the fact that some of the tasks that we were used to performing face-to-face and with physical presence now have to be performed remotely. So these are, again, these technologies that I already mentioned, but I also want to talk about a little bit about AI applications, particularly machine learning and artificial neural networks that have been, of course, explored in industry to a great extent. If you look at the number of articles published in automation construction on machine learning and artificial neural networks in the last, say, 5 years, you will see evidence of great interest among R&D professionals. To what extent those technologies are trickling down to the industry and what impact it's having on supply chains in construction remains to be seen. This is still an area of active research. And IoT applications are also making inroads, and in fact, there are some great scenarios for projects that are being run with the use of IoT technologies. My colleague at the University of Illinois is actually running a consulting company out of his own research that is based on, particularly on computer vision achievements in construction, and that is having a tremendous impact on construction supply chains. And in fact, some of his biggest clients, ironically, are not US companies, but Japanese companies. Obayashi, Shimizu, Takanaka, Kajima, Taisei, and so on, because they have this culture of adopting brand new technology and being the early adopter and then running with it once the adoption is becomes successful. But we also have a lot of developments in the area of nanotechnologies for construction materials. We have nano additives for concrete that greatly enhance concrete mix performance and can actually accelerate or decelerate maturation of concrete. We have nano coatings on various materials that prevent all sorts of adverse effects. One of my colleagues is active in developing and selling nano coatings for glass products. So imagine a window that never has to be cleaned, installed in your building. So office buildings with glass facades can downstream benefit from those kinds of technologies. And of course, we have automation and robotics applications. I've been involved in this field for the last 35 years or so, maybe a little longer than that. And I've seen a lot of changes. 30 years ago, we were promising the world, but that by the year 2000, robots will be ubiquitous on construction sites. And of course, that hasn't happened, but it hasn't happened for technological reasons. It happened because of contractual relationships between various parties to a project. So that has to do with, unfortunately, the situation which is beyond control of technology researchers or even supply chain management resources, researchers. It has to do with legal issues and contractual issues related to construction. All right, so we do have a lot of instances where Industry 4.0 is already materializing some solutions on construction project sites. So we have companies with a wide range of interdisciplinary technologies and concepts that enable digitization, automation, and integration of construction processes at different stages. So we can have seamless communications between, for example, design professionals that produce certain portions of the design, and construction machinery and equipment that can take the design data directly, say, from a CAD drawing or BIM program, and translate that data into a machine readable language for execution of certain project tasks directly on the construction project site. So the fundamental concepts of Industry 4.0, which of course is sort of a bigger picture beyond just construction, but for construction applications, we can envision smart factories for the construction environment. Of course, smart factories are part of smart construction. This is a concept that is being promoted throughout the world, of course, in Hong Kong and mainland China as well. And this allows us to employ cyber physical systems on project sites. It allows also decentralized self-organization of certain activities on project sites, which is sort of an aspect of an industrial revolution. Decentralization and self-organization of project sites, even 5 years ago, was completely unheard of, and now it's already happening as part of Industry 4.0. So we have new systems for distribution and procurement of construction materials and services, which also helps revolutionize construction supply chains. We have individualized products and services, so-called mass customization, that is possible as a result of Industry 4.0, and a better adaptation of products and services to human needs. And then from the political standpoint, we also have issues related to corporate social responsibility that allow companies to achieve greater environmental sustainability of construction projects, as well as better resource efficiency, which helps the bottom line of the projects. So here's a blockchain technology. I realize that I may be preaching to the choir to among some of you, but this is a technological solution for peer-to-peer infrastructure based on network-wide distributed databases that are linked to through so-called smart contracts, providing the business logic. Smart contracts, once the wheels are set in motion, are executed automatically, and the transactions are actually taking place as soon as a particular product or service is delivered. So alteration of these smart contracts is next to impossible. That presents one of the drawbacks of this solution. Nevertheless, there is a lot of research and development, and it's showing up also in papers being published in automation construction. A lot of interest in implementing smart contracts for the execution of construction projects. That cuts into the traditional paradigm of how projects are being administered, and the legal handover or the legal aspects of the project. A lot of lawyers are still having a lot of issues related to smart contract executions in construction. But the benefits are the faster and leaner logistics in global trade in construction materials and products of all sorts, including subcomponents for projects, especially in the industrial arena. Improving transparency and traceability in supply chains. Some of these relationships can be traced practically in real time, automatically, without involving a great deal of time and effort of professionals. And then automating commercial processes in logistics with smart contracts. It's something that the industry is looking forward to. How much resistance we will get from the current legal profession remains to be seen. Nevertheless, it's a hot topic and is being discussed throughout the US and indeed throughout the world. So this is just one example from Abu Dhabi National Oil Company. They streamline oil supply chains using blockchain technology. This is still a pilot application. Nevertheless, the company is a pioneer in the oil and gas industry, and the entire supply chain of the products that they deliver to the customer, to the market, in this pilot project has been implemented with the use of blockchain technology. So this is I'm going to leave these slides with Professor Pan and with others, so maybe you can watch these videos and at your own pace and be able to actually draw some conclusions from it, how this could be. This company needs no introduction in mainland China or in Hong Kong. Alibaba, of course, is one of the world's, if maybe the biggest online retailer. And they integrated blockchain technology to track information in its cross-border logistics operations. Details about production, transportation, customs and inspection, third-party verification is all handled by blockchains. Alibaba, of course, is not very closely related with the construction industry. Nevertheless, the paradigm implemented there may be a pattern to follow for many construction material suppliers. Especially suppliers delivering their products across the world, especially unique products such as maybe granite or marble products that need to fit the requirements of a particular designer, maybe from a unique quarry that only exists in one place in the world, and the design professional, the architect, would not budge that the pattern that they need to implement in that project can only be delivered by a certain supplier. How that is actually transferred and across various political systems, as well as the borders and the customs associated with processing these products. If it can be handled by a blockchain technology solution, it would be a great improvement over what we traditionally have in supply chains. So I mentioned briefly AI applications, and of course this is learning and action-based capabilities that mimic autonomy rather than process-oriented intelligence. We have two aspects of it. We have augmentation for the assistance to humans with day-to-day tasks to reduce errors due to human bias. And then we have automation aspect of AI to completely deliver autonomous solutions in any field without the need for human intervention. So, for example, robots performing key process steps in manufacturing plants or in construction equipment processing plants. Does it have a great chance of happening? Well, with increases in computing power, especially now with the ability to implement quantum computing eventually in the industry, a lot of the computing capability can benefit these autonomous solutions that are not very popular at this day and age in the construction industry. However, there are companies that are making inroads into that. So as far as supply chain management activities, so how can artificial intelligence be applied there? Well, just a few examples here. Chatbots for operational procurement, Machine learning applications for supply chain planning, machine learning for warehouse management, autonomous vehicles for logistics and for shipping, NLP, so natural language processing for data cleansing, building robustness, supplier selection and relationship management with suppliers also can be handled by AI, security handling as well. Guarding assets on project sites, as well physical assets as well as information that would not get into the hands of competitors. And then simplification and acceleration of decision making using AI to weave through very complex sets of data and information and being able to provide the right match of data and information for easy decision making by key individuals in a particular company. So all these are valid and important, and many of them have already been implemented in industries. I had a last minute scare because last night my internet access was interrupted at the place where I'm staying right now. So I had to deal with that, but fortunately it was all resolved. And it was entirely handled by chatbots. I didn't have to speak to a single human. In the end, actually, someone called me just to solicit my input as to how the whole experience worked out. But we're seeing these kinds of solutions throughout the industry, and they're making big inroads into construction industry as well. All right. And then as far as other solutions are concerned, object recognition at airports, what kind of luggage is moving on the conveyor belt. And there's some nice videos here that I don't really have the time to show. For example, in public transportation, I know some of you are interested in transportation solutions for the supply chain. So please, or maybe I'll just briefly run this one. Let's see, I should probably I don't know if the audio is coming across or not. Maybe not. So I don't want to belabor that subject, but I just want to simply say that there are, in fact, many solutions for public transportation that are based on AI, and especially public transport supply chains that are very attractive for use in industry. And also in the materials industry, such as steel industry, transportation of fuels, also very important for construction. So gas transport, pipeline management, but also transportation of liquefied gas through proper containers on vehicles. That is also greatly benefiting from AI-based solutions. So everybody familiar with this company, Uber, delivering transportation services. I don't know if Uber is still operating in Hong Kong. I know in mainland China, actually there is a lot of competition, and local companies have taken over. So I don't think Uber is operating in mainland anymore. But throughout the world, there have been actually a pioneer in providing mobile phone-based ability to deliver transportation. And one of the key aspects that they needed to tackle is improving location accuracy, the pickup and the drop off of the passenger, absolutely essential to their business. So they also leveraged computer vision to make the trips safer and more efficient, especially right now in the COVID-19 age and security scares. There were quite a few incidents with unsafe drivers and even bigger crime. now being able to monitor the ride from beginning to the end is a huge boost to their business. And also enhancing real-time forecasting using neural networks of supply and demand of rides for individual customers, and creating seamless communication with conversational AI, so they don't have to employ too many humans, given the fact that in developed countries, human labor is quite expensive. So we can actually multiply these examples and see how AI is making inroads in various industries. Eventually, supply chains and construction stand to benefit from all these experiences being present in other industries as well. So definitely there is a great potential, and in fact potential that is already being realized of improving transportation with artificial intelligence. All right. So as far as the improvement of supply chains using Internet of Things, so IoT applications. IoT is essentially a network of objects that have been technologically equipped with sensors to collect, exchange, and transmit data, which allows the real-time information access. So that simply means devices and objects talking to one another, exchanging data, and then allowing for useful decisions to be made on this ability to exchange and articulate data in a manner that is understandable to humans and easy to process for decision making. So the issues that can be handled using this type of technology are multiple. There are many benefits of using Internet of Things for supply chain management. So here are just a list of several of these benefits. Reassurance that goods are located where stakeholders say they are, both at rest and in motion. So being able to track your goods that are traveling. This technology was pioneered by shipment companies such as Federal Express in the US or UPS, United Parcel Service, and many similar services originating from other parts of the world. So object tracking and being able to know where the product is following multiple transactions is actually very important. Early identification of issues with goods that may get lost or delayed, hugely important for the reliability of these industries. Real-time shipment and inventory visibility and tracking, also hugely important because customers expect the ability to be able to track their shipment. And then we have supply and demand planning at stakeholders. Stakeholders know when they can expect to receive and process goods and services to some extent as well, but especially products. Think of just-in-time delivery of certain components, maybe window frames, maybe reinforcement bars that need to be inserted into formwork columns rather than storing them. So being able to facilitate just-in-time delivery with tracking capabilities and monitoring where these products are is hugely important. Then better quality management due to keeping raw materials and processed goods in optimal conditions, right? So being able to know what is the mode of transportation, how they're being delivered, how they're being loaded and unloaded, especially prefabricated components of a building, that they're properly lifted and that are not damaged during the transport. efficient storage and distribution of products due to easier location of goods in warehouses, where there is indeed a need for warehousing, storage and distribution of products. If you can locate them easily, actually saves a lot of time and money. All right. There are actually quite a bit of examples of where this logistics actually makes natural sense. So various applications. This is a New Jersey Transport Authority in the US, just very close to New York City. Advanced traffic management program developed that includes centralized federated command and control system to minimize congestion and improve traffic flow. This is actually part of the New York and New Jersey Transportation Authority. The city of New York, the whole agglomeration, is approximately 20 million people. So traffic improvements are hugely important. Port of Hamburg is the largest port in Europe. So being able to deliver the shipments in and out of the port is actually hugely important. So sensors were embedded. Excuse me just a second. When you can embed sensors in the port's main tangible assets to identify recurring underused capacity, to be able to use it properly, actually resolves a lot of bottlenecks. And the Decathlon application is about using radio frequency identification, so RFID, to deliver products with 100% accuracy. So no misdirecting of products with the use of this technology, and items arrive shelf ready, which saves employees time by not manually checking each delivery. So they're just being expedited for storage, being able to use just RFID technology. One can argue that RFID is hardly an AI application. Nevertheless, in conjunction with other technologies that can create interesting solutions where it's not only identification of delivery items, but also creating logs of products where they are stored and being able to retrieve them easily from their storage location for easy installation on project sites is already requires AI-based solutions. All right. Just briefly to talk about nanotechnology-based materials. I already mentioned that nanotechnology allows us to improve primary properties of traditional construction materials. I talked about nano coatings for glass, but also additives, concrete additives. It can also add functionalities to existing materials. So paints and coatings or glass may gain self-cleaning, also antimicrobial and pollution reducing properties as well, which is a great deal with respect to these materials. Also, we can introduce artificially designed materials to fill existing needs. Good examples here are silica aerogels for thin or transparent insulation, where we don't want to spend the volume for insulation. We can have very thin layers. We can have corrosion inhibitors for steel corrosion protection to make steel actually far more durable than it otherwise would be. We can also reduce environmental impact and energy intensity of structures, which is hugely important. Most of you would be familiar with embedded energy concept. And this is a tool that a lot of sustainability engineers use in evaluating construction construction project solutions, both in terms of design and construction site delivery, as to how much energy is required to produce all the materials for that project, and run and equipment, and then run that equipment to be able to install all the products directly on the project site, how much energy is required. And this could become one of the design parameters in many projects in the future, which hasn't been the case in the past. So this is also becomes a supply chain issue. So nanotechnology-based materials examples, there are many, but I've just listed here: self-cleaning antibacterial enamel panel, and then translucent aerogel thermal insulation. You can have a translucent insulated product, and you don't have to worry about re-engineering the entire space to be able to allow natural light in. Ultra lightweight eco insulator with palm fibers. That's another interesting solution coming out of Canada. And antibacterial dust-free air duct by nano coating. So allowing great savings on maintenance costs in the future, especially in industrial facilities that require very clean environments. All right, so I'm quickly running out of time, so I just want to show a few examples of automation and robotics, which is one of the closest areas to my heart. The ways in which construction robotics are disrupting the industry and supply chains. So, for example, masonry wall building using construction robotics, autonomous equipment that doesn't need an operator, saving on operator cost, smart robots that employ imaging technology for delivery of materials and tools, and a couple of other choices: surveillance, surveying, and inspection. Drones, of course, are now mature technology for construction site monitoring, and also heavy-duty drones that can deliver construction components directly at into the place of their assembly. And then all sorts of maintenance applications, such as red zone robotics out of Pittsburgh. This is a CMU, Carnegie Mellon University, sort of a spin-off company that has actually made its niche in inspection of buried utility pipes, both for water systems delivery, but also for other media as well, gas pipes as well. Now, coming to the 3D printing technology applications, a hugely disruptive technology that allows the execution of the process of joining materials layer upon layer to make objects from 3D model data. So think of regular 2D printing and adding a third dimension and creating three-dimensional products. What is the influence on supply chain? Well, mass customization, similar to that of manufacturing industry, of car industry. You can hardly find two identical vehicles in the world anymore, even if it's the same model, same make. But the various options that a particular vehicle would employ would make it a unique product. And by the same token, you hardly ever see two identical buildings. Even if the design is the same, but the location would be different, that requires different technological solution, different load-bearing capacity of the foundation, for example, would require a different foundation solution, different options in the building. So mass customization using 3D printing is hugely important. Caterpillar Construction Equipment Company, one of the biggest in the world, has purchased now a 3D printing company just to be able to produce relatively small 3D printers with which they would equip equipment operators running projects in remote areas. So when an operator needs to find a replacement part, maybe a gasket or a particular nut or bolt that is in short supply, rather than ordering it from a supply store and waiting 24 or 48 hours to be delivered and wasting precious time, he or she can actually program their laptop computer connected to the small 3D printer, go to sleep, and when they wake up in the morning on the project site, that product would already be printed and ready for installation in the machine. So resource efficiency can be a lot greater using 3D printed products than with traditional manufactured products, simply because 3D printing promises zero waste. Decentralization of manufacturing, of course, is a very important issue, and the reduction of complexity of the supply chains. If you can actually print products directly where they need to be located without the need for transportation. So rationalization of inventory and logistics can actually follow suit as a result of the implementation of 3D printing. And then product design and prototyping can benefit from 3D printing as well. There are some legal and security concerns, of course. One of the security concerns in the US is that we have now 3D printers that allow you to print a weapon, like a gun, from plastic materials that would pass through security screening at the airport, metal detectors. So how do you guard against that? That's an issue. Overcoming geopolitical risks and tariffs, actually delivering products by 3D printing technology rather than shipping them from one country to another. And then reduction of supply chain parties, how many different parties that supply chain would have to contain. That's another potential benefit that supply chain management researchers might wish to explore. There are numerous examples of 3D printing applications in aeronautics. I already mentioned printing replacement parts. I mentioned Caterpillar, but Siemens is also one of the pioneers for printing replacement parts, especially for gas turbine plants in Sweden. IKEA, a famous Swedish furniture company, is experimenting with 3D printing in the context of design for smaller items that need more complex designs. Why actually bother with traditional manufacturing if you can print a particular component? Ford, being one of the three large US automotive suppliers, they print tools for production processes and large scale car parts, again, saving material. All right, so a few examples of 3D printed buildings, such as this one printed 2 years ago in Austin, very small one. And this is a French example, Innova project in Nantes. So about 3 years ago, material is polymer with concrete inner layer. Technology that delivered this building is a robotic arm. I'm going to run through these examples fairly quickly. This is a 3D printed massive house, again, 2018 in Milan, Italy. Fairly small area, but the time of delivery for this building was 48 hours, so less than 2 days and 2 nights. Material is cement-based. They all require robotic arm as the means of production. So this is another snapshot of how this building was being produced. This is a smart bar MX3D, a famous Dutch company that has the capability of actually extrusion of construction material. So they actually built this bridge using extrusion techniques. This is a footbridge, but larger bridges are being produced like that. In mainland China, Hebei Institute of Technology. I think it was a concrete footbridge that is 3D printed from segments on their campus. So lots of fantastic shapes can actually be produced using this technology. So it doesn't have to be just rectangular shapes or those that are traditionally procured, but shapes like this, like the butterfly screens and fantastic shapes that can only be delivered using this sort of technology. All right, in China, of course, there is a lot of developments related to 3D printing in construction. Winsoon is one of the companies that is very popular on the internet. You can find a lot of solutions proposed by Winsoon. I think they're based in Shanghai and Shenzhen, and delivering villas and multi-story buildings, not very tall buildings yet, but also contracting with Dubai municipal government for a bus station, building deliveries, all kinds of things. A Russian company by the name of Apiscore is also very popular and does that actually in very cold climates as well, in temperatures maybe minus 30 degrees Celsius, building small buildings. All right, so 3D printing is indeed here to stay and make inroads in the construction industry. One of the, actually we're about to publish, Svetlana and I were about to publish a paper in ASC Journal of Construction Engineering and Management, how 3D printing technology is going to be used in the reconstruction of the Notre Dame Cathedral in Paris, France, which, as you may remember, a year and a half experienced a massive fire. So it was almost completely destroyed. But fortunately, there are digital images, 3D images of that structure in great resolution that would allow 3D printers to be employed to produce many of the components that would otherwise be extremely difficult to produce using traditional technologies. So we're describing that example in the paper. So those of you who are interested, I think maybe next month or so, that paper will appear. So Notre Dame might be reopened, at least partially, to visitors within several months. The promise that is being made right now is to restore the entire cathedral in 5 years, which using traditional technologies would be extremely difficult, if not just plain impossible. So no need to train large crew. Otherwise you would need to train from scratch about 400 craftsmen. Using 3D printers, you don't have to worry about that. So 3D printing technology issues actually have some supply chain problems as well. So quality problems, precision of printed objects, resistance to environmental influences, and quite a bit of others that otherwise wouldn't have to be researched. So this is one of the things that we're trying to do. We're creating a technology capability map for 3D printing. There are companies that specialize in various aspects of this technology, but in order to integrate those aspects for delivery of a large construction projects, they need to join forces. So this is work in progress, where you can actually show where the companies are located in the world and how they could possibly be tapped and join forces for the conduct of a particular project. What are the technology capabilities that they have, and how those technology capabilities can be matched with other companies that have complementary capabilities in order to be able to deliver a particular construction product. That hasn't been done yet and implemented in industry, so this is still in the research stages. Nevertheless, we want to produce this interactive map for these companies to be able to access one another's resources. So This technology capability map will likely result in the development of new structural systems, and management of 3D printing construction projects will also be greatly enhanced by being able to use this technology capability map. To what extent it'll materialize in the near future depends on the interest of not only contractors, but especially construction owners that want to utilize this technology. And we want to be able to be of help. So this is just a screenshot of one of the latest versions of this technology capability map. Those of you who are interested, we actually proposed it to Hong Kong CIC at one point in time. And CIC was ready to support this project to be able to implement it for the Pearl River Delta area. So obviously of direct interest to Hong Kong, because there are numerous companies in the Pearl River Delta that have various capabilities related to 3D printing, and that they can accelerate the use of 3D printing technology for construction projects, specifically in Hong Kong. And of course in Shenzhen and Zhuhai, maybe in Guangzhou as well. But the primary focus would actually be Hong Kong. So actually I'm completely out of time, so I don't want to belabor the technology capability map utilization, but we're in the process of actually refining this, and we should be able to show you more at the next available opportunity. All right, so with that, I think I'm going to, well, there's still some slides left to explain, you know, what these companies participating in the technology capability map are right now, and we should be able to belabor on that, as I said earlier, in the near future. All right, so let me just open it to questions and answers. I'm just showing some slides indicating that extraterrestrial construction will also be possible, primarily with 3D printing, that would otherwise be impossible with less disruptive technologies, simply because it's just too expensive to ship construction materials from Earth to other planets. So here we are. Thank you very much for your attention. I'm going to stop my screen sharing and allow questions to be asked. Thank you so much.
Thank you very much, Professor Skibniewski, for your fantastic lecture, which covered a long list of innovative technologies. Really, they are the disruptive technologies we are witnessing, like AI, big data, blockchain, IoT, robotics, automation, 3D printing, very good details. I think this is a fantastic lecture, not just for the researchers, because we did have over 80 participants, and also plus the few people in this panel group. So while we're getting questions, and Dr. Zhong, do you want me to raise maybe?
Yes, please, Professor Pan. Yeah, we do have some questions from Q&A and the chat channel.
Okay. Yes. So perhaps while we're receiving more questions, I can ask the first one. So out of the many disruptive technologies, a little bit overwhelming, Professor, could you advise us on the three most important things for construction supply chain?
Okay, I would put on the top of the list the one that I talked about the last, and that is 3D printing, because this is a very, very hot technology that promises not only disruptions in how construction products are being delivered to the project site, but also revolution in the construction materials industry. Because currently about 80% of the entire effort and expenditures, in fact, related to 3D printing and construction goes into materials research, and only 20% to something else. But I think that eventually supply chain related research for 3D printing and construction will be inevitable. And a lot of attention will be spent on supply chain engineering and supply chain management. The second disruptive technology would be robotics. Robotics, especially for tasks that are high volume, relatively easy for humans to perform, but also being performed in dangerous areas, or areas that are just, or work environments that are just plain unhealthy for humans. Either because of high levels of pollution, and that includes maybe high levels of dust, high noise areas, and wherever you may have chemical agents present that may just harm human workers. Robotics. And the third one is not really related to the either equipment or the technological process, but it's more related to materials. And in my opinion, that is actually nanotechnology. New materials that will be engineered specifically for particular applications, and nano coatings or nano insulation materials that will be engineered to fit the need of the architect for installation in a particular structure. So those three will be the ones that I would put my bets on, that would be most disruptive and the most influential in the next couple of years.
That's very good. Actually, we have got a related question from a first-year PhD students. The question is there any limitation of 3D printed materials in construction? And this students also gave an example. For example, the traditional construction, there is a variety of materials like rebar in concrete. So could you advise on any limitation of that?
Well, there are numerous limitations related to those materials, especially when it relates to concrete, because rheology of construction materials that are being used for 3D printing is not very well researched. The durability of these materials and their ability to withstand certain adverse effects, especially chemical corrosion, there's just not enough research at this point in time. When it comes to reinforcement of concrete, of course, traditionally they have been, or traditionally, this is such a new area, but traditional thinking about the best solution for reinforcement would be fiber reinforcement. Either steel or composite fibers, or even mineral fibers such as basalt, were considered to be the most viable solutions. But now there is a great deal of effort by especially Dutch researchers from Delft, University of Technology, and some of the Dutch companies in the Netherlands, in conjunction and collaboration with Singapore, to actually produce concrete structures together with steel reinforcement, traditional reinforcement, all in one sweep, in the same vein. This is a technology that is not widely publicized at this point. They're trying to get a patent on it. I actually served on a couple of review panels for funding agencies that they try to tap resources from to be able to come up with these solutions. it's quite promising. But still, severe technological limitations when it comes to equipment. Design and implementation of construction equipment in conjunction with 3D printing will be another interesting area of research and development that some of you may be interested in to participate actively.
That's very, very good. I very much agree. I think the new technologies lead to a new way of structural design. So we don't have to follow the traditional structural design with rebar, and we can always have this fiber reinforced concrete, you know, including the steel fiber and so on and so forth. And another question here is related to blockchain technology. And some people argue blockchain technology can lead to decentralized management. So the question is, would blockchain technology cause negative influence for construction supply chains, such as reduce the decision-making efficiency?
Well, that's a very good question, because nobody knows that for sure yet. We can actually streamline and deliver greater efficiencies of the execution of the transactions without the use of human intervention. But when it comes to handling a potential dispute, or if there is a malfunction within the blockchain to actually undo what has already been done, you know, money, for example, would have changed hands inside the blockchain-based solution. To be able to undo that and extract reverse payments from other parties, that may prove quite difficult. To some extent, the implementation of blockchain indeed may decrease our ability to effectively manage projects, especially from the standpoint of human control over what actually goes on. This is a valid concern. I wouldn't pretend otherwise, but it has to be weighted against the benefits of blockchain technology. To what extent the benefits will outweigh the risks and the potential pitfalls with the use of this technology. This sounds like a great research project for someone who wants to do a PhD on that topic, to actually model the risk and create a risk register with respect to all the things that will go on in a construction project when a blockchain-based solution, say a smart contract, is being implemented. Being able to show these pitfalls either through simulation or through some interesting case studies that may be analyzed, I think would be a fascinating study to consider.
Thanks, Professor Skibniewski. We in the audience, I think we got not just the engineering PhD students researchers, so we also have some management researchers. So and there are some questions related to management. So the first one is, in the traditional research in prefabricated construction supply chain, the scholars tended to follow the linear model, and not many consider the circularity in the prefabricated construction supply chain. And do you have any advice to offer in terms of the possible integration between the prefabricated construction supply chain and the circular economy?
Wow, this is a very, very complex question, because the impact of prefabrication on environmental health and environmental efficiency has been tackled by a number of researchers in the past, but that was primarily in the context of traditional prefabrication. And what will 3D printing technology do? What will what will blockchain technology do to prefabrication, and how that would impact circular economy. I'm very supportive of circular economy because I think we really need to be prudent and good stewards of our resources. And not only that, but we have to give back to our environment what we have, or we or other people, other industries have done to damage that environment. So with the use of these disruptive technologies that I try to talk about today, and prudent, very clever use of prefabrication, I think the sky is the limit as to what we can do, how we can improve the circular economy, and how we can improve construction to actually become a greater contributor to the circular economy, and how to make construction more environmentally sustainable. But this is sort of a very generic and very general answer to a specific question. I'd rather discuss the impact of a particular disruptive technology on prefabrication rather than all technologies in general, because different technologies will make different impacts on prefabrication.
Indeed. A follow-up question here on the economy side. Most of the disruptive technologies you have mentioned, they probably engage higher capital cost, some capital investment. So how do you consider the cost and benefits of these technologies?
Well, different technologies would require different capital investment, and it really depends on which particular snapshot of the entire process you take into account. Let's say you're an equipment operator and you want to invest in a 3D printer to print your spare parts. The capital investment in that would be relatively small, because all you need to do is to purchase a printer, maybe a couple of $100, maybe, I mean, I'm talking US dollars, or at most a few $1,000s, and then investment, of course, in that material. And of course, you have to train yourself in the efficient use of that printer. But then if you take a bigger snapshot, of course, you have to look at the entire supply chain and the impact of that solution on the supply chain. If you look at automation and robotics, for example, if you look at it from the perspective of robot system developer, of course, there's an R&D cost, which rarely goes below $1 million US to successfully deliver a robotic application to the industry. But if you look at it from the standpoint of an individual contractor that can actually rent or lease that robot to perform a particular task, then that capital outlay may not be necessarily as large, depending on how many of these machines you can actually deliver to the market. If you're a vendor, R&D vendor, there's a company in the US called Construction Robotics, which is a masonry robot developer based in Rochester, New York. And from their perspective, if they can deliver 20 of these machines per year to different contractors, they can stay in business. They can actually, the difficult part is to developing the first prototype and making sure that all the bugs are worked out. But once that prototype is developed, then the mass production, or at least the production of multiple machines, would be relatively easier and cheaper for them. And as long as they can keep the demand going and increasing, the company actually can stay in business. So the capital outlays really depend on your perspective, where exactly in the supply chain you're located. Are you an R&D vendor that delivers these products to the market, or are you a contractor that is just adopting the existing technologies and equipment for their own use, or whoever else you are, you'll have a different perspective on that issue.
Indeed, indeed. Dr. Zhong, how do we get on with the time?
I think we can take maybe one more questions, and we can close this session.
Yeah, we have got a lot of questions.
Yeah.
Perhaps I can ask the last question.
Yes.
Which is to ask this question on behalf of many young researchers. A lot of disruptive technologies were mentioned in a great talk. What advice would you give to the young researchers in the field of construction supply chain?
That's a great question. It really depends on your personal background. If you're a construction engineer, for example, you might want to select for yourself one of these disruptive technologies and make the best use of it to improve the construction process. If you are, let's say, a technology researcher, you might want to look at the entire spectrum of technological solutions and how they impact the construction industry at the industry level, not on the particular project level, but at the industry level. If you're, let's say, a computer scientist and a software person, there is a great deal of need. There's a need to deliver software solutions for these applications, and one of the biggest ones is actually simulation. Being able to create and then integrate various simulation tools to show how these tools can be used in the analysis of the solutions before they are physically delivered to project sites. And of course, how to integrate these technologies with existing legacy systems in companies. So for example, with BIM technology, or with project management tools, software tools. If you're a materials researcher, then sky is the limit for you. You can talk about developing new materials. You can talk about enhancing existing materials. You can do a lot of laboratory work to show that a particular material that you will engineer will be over and above what's available out there in industry, and you'll make a tremendous impact on facilitating the use of that technology with the material that you will be working on. Well, and since some of you are management researchers, then of course the impact of all these technological solutions, not just on the supply chain, composition and performance, but also, what are the changes in the paradigm of project management to manage construction projects with the use of these disruptive technologies. So really, you have a wide spectrum of topics that can be tackled in research and development, depending on your set of skills and on your industry perspective, and just your academic field that you're representing.
So, excellent. Thank you so much.
And those of you, thank you, Wei. In fact, those questions that I couldn't address because of the limitation in time, if you could possibly compile them and give me contact information for the students and others who tried to ask them and didn't get a chance, I'd be happy to answer them by email.
Okay. Many thanks. Dr. Zhong, over to you.
Yeah, thank you so much, Professor Skibniewski and Professor Pan. So may I invite Professor Heng Li to say some few words?
Yeah, Merrick, I didn't have a chance to ask you. I think that your talk actually is very comprehensive. It has full coverage of all the important issues of our domain. As a typical academic in Hong Kong, we always puzzled with this. You know GIF, right?
Yeah.
General Research Fund. The selection of topic. In Hong Kong, except a few exceptions like Professor Pen Wei, many of us are having great difficulties to get this funded. Now,
I'm just reviewing a few proposals for GRF right now.
Yeah, no. Because you are very abreast with the exercise in Hong Kong, and also NS, you work around, basically what's going on, worldwide. So my question is, among all the topics, if I have this choice, and what I should select to do in my next GIF topic?
Wow, that's a great question. But please don't blame me if that topic is ultimately not accepted by the reviewers, because everybody has their own preferences. Remember, you and I, last time I was in Hong Kong, we talked about biologically inspired solutions. And what can we learn from nature, and how nature can not only inspire but guide us in arriving at solutions that would otherwise be maybe less efficient. Examples of that would be to look at paradigms that insects use to come up with assembly of a complex structure, right? And try to match that those observations with what technological solutions, those disruptive technologies that I talked about, what they, how they can contribute, not alter those biologically inspired solutions, but how can they enhance and how they can facilitate these solutions, and combining disruptive technologies developed by humans with solutions arrived at by other biological organisms, non-humans, could be an interesting study, something that I don't think anybody has done at this point in time. So remember we talked once about publishing a paper in Nature, or one of those journals that have an astronomically high impact factor. This could qualify for something like this, for a publication. But I'm not just talking about publications. I would be more concerned about the industry uptake of a solution like that. What would the impact on, let's say, architectural design or structural design be of an idea like this, or how that would propel new developments in construction materials, or means and methods, especially construction techniques. So showing that match and showing the inspiration from these biologically inspired solutions would be, in my mind, would be quite interesting. In fact, I'd be interested in collaborating with someone on a project like that.
All right. I'll write down and start to to get started and then ready.
Okay.
By June. Okay. Oh no.
All right.
It's all October.
Yeah. Okay. Okay. So we can follow up on that.
Yeah, we'll follow up on that. Thank you so much.
Thank you. My pleasure.
It's a wonderful lecture. You always I feel I've learned a lot.
Thanks so much. Thank you.
If Wei gets the PowerPoint, please forward to me. I might pinch something and to add on my lecture notes next time. It's great. Yeah, thank you.
Okay.
Great to see you. hope to see you physically in Hong Kong very soon.
I hope so too, as soon as the pandemic's over.
Yeah, yeah.
I'd love to come.
Yeah.
And of
Yeah,
course,
I'll get
you're
back
welcome to
you
come
now.
to Maryland anytime.
I think America has a long, hard hour talking. Maybe Mick deserves some rest now.
Yeah.
It's great.
No, I'm fine. I'm fine. I just want to wish everyone a very, very happy New Year of the Ox. I know you're on the cusp of the new holidays. I know everybody's looking forward to it. I hope you don't have to travel too far, because travel is still not very safe. But enjoy the time with your families, enjoy the time with your friends, and have a wonderful, wonderful New Year. New Year of the Ox.
You too, Merrick. Keep safe.
Yes,
Stay
thank you
safe.
so much, Professor Henley, and wish a happy Chinese New Year for everybody. I think this is the end of the invited talk, and thank you everybody. Please take care, stay